in this problem, long cylindrical steel rods has a density of 7833 kg per cubic meter and specific heat capacity of 0.465 kilojoules per kilogram times degree Celsius of 8 cm diameter are heat treated by drawing them at a velocity of 2 meter per minute through an oven maintained at 900 degrees Celsius. If the rods enter the oven at 30 degrees Celsius and leave at a mean temperature of 700 degrees Celsius, determine the rate of heat transfer to the rods in the oven. So, this is the figure for this problem. We have the oven and the steel rod. So, the thermal properties of the rods are constant. The changes in kinetic and potential energies are negligible. So, the density and specific heat of the steel rods are given. So, noting that the rods enter at the oven at a velocity of 2 meter per minute and exit at the same velocity. So, we can say that a 3 meter long section of the rod is heated in the oven at 1 minute. So then, the mass of the rod heated in 1 minute is mass is equal to the density times the volume. So we know that volume is equal to length times area. So it becomes the density multiplied by length times area. Since we are given with diameter, for the area we use pi d squared over 4. So substituting the values, we have 7833 kg per cubic meter for the density, multiplied by the length of 2 meter, multiplied by the area of pi times 0.08 squared meter over 4. So, calculating this in our calculator, we get 78.75 kg. So, for the mass, we have 78.75 kg. Next, we take the 2 meter section of the rod in the oven as the system. The energy balance for this closed system can be expressed as E in minus E out is equals to the change in energy. So it becomes Q in, or the heat that in, is equal to delta U, or internal energy of the rod. And it becomes mass multiplied by internal energy at state 2 minus the internal energy at state 1. Then it becomes the mass times specific heat capacity multiplied by the temperature at state 2 minus the temperature at state 1. Since we have these values, all of this has a values, so we just plug in it. We have the mass of 78.75 kg multiplied by our specific heat capacity of 0.465 kilojoules per kilogram times degree Celsius multiplied by our T1, or temperature at state 2, which is 700 degrees Celsius, minus T1, or the temperature at state 1 of 30 degrees Celsius. So solving this, we have 24,530 kilojoules of heat in. So now, we can solve for the rate of heat transfer to the rods in the oven. So noting that this much heat is transferred in 1 minute, the rate of heat transfer to the rod becomes the rate of heat in is equal to heat in over delta T, or change in T. So for our heat in, we have 24,530 kilojoules over our time of 1 minute. Since we are given of kilojoules per minute, to convert it into kilowatts, we have to multiply it by 1 over 60, since 1 minute is equals to 60 seconds. So, from 24,530 kilojoules per minute, it becomes 409 kilowatts. So, the rate of heat transfer to the rods in the oven is 409 kilowatts.